Today we are going to start new topic that is probability. So in this probability, so first of all, welcome to you all. And today I didn't have my smartphone. That's why maybe it is difficult to be in live chat. Okay, so please try to cooperate. And before doing the problem, I will give some specific time to you. Okay, so do the problems carefully. Okay, yes. So in this, yes, who is coming? Manjula as well as Rajani. Hi, namaste. Anita, namaste. Okay, yes. See the condition. First of all, we will discuss the definition of probability and what are the main conditions of probability. So in this probability we will have main conditions. Those are, first one is random experiment. Okay, so what do you mean by random experiment? Random experiment is nothing but an experiment in which outcomes cannot be determined. Outcomes cannot be determined. So we should not expect outcomes. Then only we can say that that experiment is called random experiment. Example, we can take tossing a coin. Tossing a coin. By tossing a coin, we cannot expect what it will be. Okay, na? What the result will be, we cannot expect. That's why this tossing a coin is called random experiment. Or rolling a die. Rolling a die. So this is also an experiment in which the outcomes will be, outcomes means results, 1, 2, 3, 4, 5, 6. Anyone may come, we cannot expect. That's why this is called a random experiment. Okay, so random experiment we will have. Now let us see. So what is after random experiment? We will go through one more condition, that is sample space. Sample space. Okay, na? What do you mean by sample space? Sample space means the set of all outcomes. The set of all outcomes of random experiment. So the set of all outcomes of random experiments is called sample space. What do you mean by set of all outcomes? Example I will take. Generally sample space we will denote with S. Okay. So in this, if I toss a coin, by tossing a coin, what the outcome we get? By tossing a coin we will get the outcome as head, tail, right? So these outcomes I have written in a set. That set is called sample space. Okay, next I will move on to one more condition. By rolling a die, by rolling die we will get the sample space as 1, 2, 3, 4, 5, 6. Okay. Suppose if we toss two coins, here one coin we got this outcomes. By tossing two coins means what we get? Head head as well as tail tail as well as head tail tail head. So these are all outcomes of the sample space. Okay. So once again I am reminding you, actually I didn't have a smartphone right now, that's why I unable to be in live chat. Okay na? So please try to cooperate today. Okay, just a moment. Hello. Sanju. ఓకే 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 సరే, అది ఒకసారి చూడు, వస్తుందా చూడు, ఇప్పుడు చెప్పేది వస్తుందా చూడు ఒకసారి. రైట్, ఓకే ఓకే, ఉంటా. ఓకే, now by tossing a coin we got four outcomes. Four outcomes means we will get 2 square. 2 square is equal to 4. If we toss a coin for 3 times, then the sample space will have total 2 cube outcomes will be there. 2 cube outcomes means 8 outcomes. So like we will have head head head, next head head tail, as well as head tail tail, next as well as head tail head, and here t t t, next t t h, t h h, t h t. So these are all outcomes we will have. Those outcomes will be 8. If we toss 4 coins, we will get 2 power 4 is equal to 16. In that way we can do. Next, if we toss a die, if we roll a die, then we will have, what are the outcomes? Already we have seen 1, 2, 3, 4, 5, 6. If we roll 2 dice, 2 dice rolled means we will get the sample space as 1, 1, 1, 2, and so on up to 6, 6. Total 36 will be outcomes. If 3 dice are thrown, 3 dice are thrown means 1, 1, 1, 1, 1, 2, like that, 6, 6, 6. Total 6 cube is nothing but 216. Total 216 outcomes we will have. Okay. So this is about sample space. Next, event. So this is a frequent question or frequent condition in probability. What is event? Event means any subset of sample space. Any subset of sample space is called event. Any subset of sample space. Like we have taken, what are H, 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 T, T I have taken. So we can represent a number of subsets like this: H, H, T, 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 H, H, T I have. So in this I will take only 2 set of elements, that means H, H, T, T. This is subset of this set, that's why this set is called event. Okay, so event is nothing but any subset of sample space. Any subset of sample space is called event. Okay na? So there are many types of events, but majorly we will discuss only 2 events. Those events are mutually exclusive events. Mutually exclusive events. These are important conditions. Mutually exclusive events as well as mutually exhaustive. Mutually exhaustive events. Total two types of events will be there. Major means different types are there, but major among those these two important. In mutually exclusive events, first I will take suppose two events E comma F are two events. Mutually exclusive means the probability here the events mutually exclusive means the intersection of the two events should be empty. Then we can say that those two events are called mutually exclusive events. Example, I will take one example. Suppose S is equal to, I will take 1, 2, 3, 4, 5, 6. So, this is sample space. In this, I will take two events. First one is even numbers. Even numbers means what we will have? 2, 4, 6. This is one event. I will take one more odd numbers. F is equal to what we will have? 1, 3, 5. So here E intersection F is equal to empty. That's why these two events are called mutually exclusive events. Okay. One more, mutually exhaustive. E comma F mutually exhaustive whenever the union should be equal to sample space. Sample space. Okay. So here E union F should be sample space. Means what? Same example I will take. Here what we have, E is equal to 2, 4, 6 and F is equal to 1, 3, 5. Okay. So I will do E union F. E union F is equal to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 means what I got? Sample space. Okay. So sample space means we can say that these two events are mutually exhaustive. Mutually exhaustive as well as mutually exclusive. These are best example for exclusive as well as exhaustive. Okay. So now I'm going to write the original definition of probability. Probability main definition. Probability is nothing but if there are equally likely events of an event of a sample space S. If there are equally likely events, equally likely means same probability should be there. Then the probability of E is nothing but number of favorable outcomes upon total number of outcomes. Total number of outcomes. Okay. So this is the main definition of probability. Okay. The probability of an event is number of favorable outcomes divided by total number of outcomes. So based on this property, we will do so many problems. We have plenty of problems to do. Okay, so this is about main definition. And probability of an event should be always between 0 to 1 only. Okay, so 0 to 1. It should not less than 0, it should not greater than 1. Okay, this is most important condition. Probability should be always, it will be 0 to 1 itself. Okay, next, after that, uh, next one more. See the condition. Here in this we have the probability range we have seen, and one more useful condition, the probability of two events E union F, or we can say that probability of E or F. What is probability of E union F formula? Probability of E plus probability of F minus probability of E intersection F. So this is also one of the important formulas. We will use this formula in further. Okay, so probability of an event E or F. Okay, here two conditions, R is nothing but union and is nothing but intersection. We need to remember these two properties. Okay, this is about E union F. Next, one more will be there, complement of an event. The probability of not E. What do you mean by probability of not E? Probability of not E means E dash. Okay, so not E means, it means 1 minus P of E. Here 1 is nothing but total probability. Probability of sample space is always 1. Okay, how this is always 1? For example, S is equal to, I will take 1, 2, 3. Probability of sample space is equal to favorable 1, 2, 3, total 3 numbers, divided by total also 3 numbers, that always 1. So total probability will be 1. So probability of E dash is equal to 1 minus P of E. So this is about complement of an event. Okay, so these are majorly useful formulas. If any more formulas will come, I will explain at that problem. Yes, let us see our first problem. Okay, so see the question. Probability of getting heads by tossing a coin. It will be easy to everybody. Probability of getting heads by tossing a coin. Okay, guess what will be the answer? Simple. Solution I will write. By tossing a coin, by tossing one coin means the sample space will be heads or tail. Now the probability of heads, my favorable is heads. How many heads will be there? 1 out of 2. So the probability of heads will be 1 by 2. Similarly, probability of tails, same 1 by 2. Okay na? So this is easiest problem you can do. Okay, now one more problem came. See one more problem. Solution. How to do this? The probability of getting at least one head by tossing two coins. At least one head. So once again I'm saying I unable to be in live chat. You have to cooperate today. Okay. So see this. The probability of getting at least one head here, at least, at most, two conditions will be there. At least means greater than or equal to, at most means less than or equal to. At least means minimum, at most means maximum. Okay. So these are two frequent words, at least as well as at most. Okay na? See, at least minimum one head required. Then by tossing two coins, sample space will be, I am tossing two coins. What will be the sample space? Head, head, tail, tail, head, tail, tail, head. Okay. You can guess the answer. What will be the answer? So, at least one head means my favorable event is minimum one head. I can take this 2. Here, I won't take this HTTH. At least means one head or two heads. Here 2, here 1, here 1. Okay na? So minimum 1. Then what is our probability? Probability is nothing but favorable. Favorable how many? The cardinality n of e is equal to 3 out of total how many? 4. The answer is 3 by 4. Okay. So 3 by 4 is correct answer. This is about cardinality of number. N bole to n means cardinality. Okay. Similar problem we will do one more problem. Okay. I have written only prob means probability. Just remember probability of at most one head. Next question. By tossing two coins. Check it. At most one head, maximum one. So at most means less than or equal to. At most one means it may be 0 or 1 because 0 means no head. Okay. See solution. I think you got the answer. But even though, let me check it once. The probability of at most one head by tossing a coin for 2 times sample space is head, head, tail, tail, head, tail, tail, head. Okay. So this is about sample space. In this, at most one head, maximum one means my favorable is here one head, here two heads we should not take. Here one head we can take, one head we can take, 0 head. Here 0, there is no head. 0 we can take. So TT, HT, TH. Okay, three events, that means the three sample points I have, then the probability is equal to 3 out of 4. The answer is this one. Okay, I think you got the difference between at most as well as at least. Okay, so this is about at most as well as at least. Now I will move on to one more problem. This is also easiest one. You will do within one step. What is the problem? So we will move on easy to hard method. Okay, so check it at once. The probability of getting digit 5 by rolling a die. This is the question. The probability of getting digit 5 by rolling a die. The options are 6 by 5, 1 by 5, 4 by 5, 5 by 5. 5 by 5 is nothing but, of course, it is 1, that is total probability. Yes, you can guess the answer. What will be the answer? The answer is simple. By rolling a die, we will have sample space 1, 2, 3, 4, 5, 6. Okay, these are all favorable outcomes. Die means it will have 6 faces. 6 faces like this. First phase 1 will be there. Second phase 2 will be there. Third phase 3 will be there. Fourth phase 4 will be there. Okay, like this we will have 6 phases. My favorable is digit 5, only one number. So probability is nothing but favor divided by total. So favor is 5 means 1, only 1. This is only 1 divided by total 6. Okay, I think answer was not there. Here you have to write like this, 1 out of 6. Okay, so the option will be this one, favorable by total. Favorable digit is only one number, that means 1 by 6. Next, one more question. What is the probability of getting even or odd numbers on a die? My favorable is even numbers, or we can take odd numbers. How can we write? The sample space as 1, 2, 3, 4, 5, 6. My favorable is odd. Let me say odd. Odd is my favorable. What are odd numbers? 1, 3, 5. So the probability will be, what is cardinality of this? Number of odd is nothing but 3. So 3 out of 6. 3 ones are 3 twos are. So the answer is 1 by 2. Okay. So the probability of getting odd number, maybe even also same. Even is also same. Even is nothing but what is 2, 4, 6 favor. That means probability is equal to 3 out of 6 is nothing but 1 by 2. Very easy. You can do the problem easily. Now, let me move on to one more problem. See another problem. What is the probability of getting multiple of 3 by rolling a die? This is the question. What is the probability of getting multiple of 3? Okay. Check what will be the answer. You will have sample space. You will have sample space. What is that sample space? 1, 2, 3, 4, 5, 6. This is sample space. And by what is given? Multiple of 3 is my favorable. Multiple of 3 is nothing but, what do you say? Suppose E I will take multiple of 3 means 3 as well as 6. Because 3 ones are 3, 3 twos are 6. In this only. My favorable, how many we have? 2. Here how many we have? 6. So the probability will be 2 out of 6. That means 1 by 3. Okay. So remember, probability always should be between 0 to 1 only. 1 by 3 is nothing but 0.33. It lies between 0 to 1. Okay. Nice. In a similar way, I will give one question. What is the probability of getting multiple of 7 by rolling a die? This is the question. Anybody can guess? Multiple of 7 by rolling a die. Check it once. By rolling a die, we need to get multiple of 7. Actually, we have sample space here. Okay. So in this, what about E? Multiple of 7 is equal to 7, 7 ones are 7, 7 twos are 14 and so on. But we didn't have, because we have only the numbers between 1 to 6. That's why probability of E is equal to 0 out of 6, because there is no common element of this set. So the probability is 0. There is no probability because there is no any element which are multiple of 7 in sample space here. Understood? Okay, then let me move to one more. See this. This is one of the important problems. Check the question. Probability of India win in India versus Pakistan match. What is the probability of India win in India versus Pakistan match, whatever the match may be? Okay, match means let us assume cricket. This is the question. This is previous question. Okay, so what is the probability of India wins? Any guess? So simple. First of all, I will take a sample space. Here, what are the choices are there in a match? Maybe win, maybe loss, maybe tie. Okay, so don't say that the match was abandoned due to rain. Okay, because I am saying that winning choice. Okay, so win, maybe lose, or maybe tie. These are three choices are there. What is my favorable? My favorable is India to win. Okay, to win, I have one option. Total options are how many? Three options. Then the probability of winning is 1 out of 3. So the answer is 1 out of 3 is correct answer. Okay. So winning is 1 out of 3. Lose is also 1 out of 3. Okay na? So this is the method to find the probability. Next, let me move on to one more problem. Yes, this is the question. Some problems will be like this. Non-leap year, leap year. First, let me read the question. Probability of 53 Mondays in a non-leap year. This is the question. Okay. First, we need to see about leap year as well as non-leap year. Okay. What do you mean by leap year? Leap year next to non-leap year. Non-leap year. Okay. So, in leap year, total 366 days will be there. 366 days will be there. Means total how many? 52 weeks will be there. 52 into 7 plus 2 days. This is the concept. In leap year, 366 days. That means 52 into 7. 7 to the 14. 364. 364 plus 2. 366 days. In non-leap year, 365 days will be there. 365 days means 52 into 7 plus 1 day. Okay. Here this is 364 plus 1. 365 days. Total 365 days will be there in non-leap year. In leap year, 366 days. So, the question is asked in non-leap year. Okay, na? See carefully. This is important problem. So, in non-leap year. So, non-leap year means this one. Total 365 days will be there. Among them, 52 weeks will be there. Plus 1 day will be there. Okay. So, 53 Mondays. 53 Mondays means here may be choices of 52 Mondays. But in question what is asked? 53 Mondays. That means this also should be Monday. Okay. That also should be Monday. That means in a week we have In a week we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Total 1, 2, 3, 4, 5, 6, 7. Total 7 will be there. My favorable is Monday. 1. Then what will be the probability? 1 out of 7. Probability is 1 out of 7. Okay. Once again I am reminding, in non-leap year, I will do problem based on leap year also. Okay na? Next problem will be based on leap year. But in non-leap year, we will have 52 Mondays extra one day. But my favorable is one Monday, because total 52 plus 1 is equal to 53 Mondays. I need 53 Mondays. Okay na? Right. So this is the method. So the answer is 1 by 7 is correct answer. Okay. Nice. Let me move on to one more problem. This is the question. Just what I said. So, in leap year, what is the probability to get 53 Mondays? Okay, 53 Mondays means, I will write like this. This is little bit of different question. Leap year means leap year. Leap year means 366 days. 366 days means 52 weeks plus 2 days. Okay na? 52 plus 2 days. Here 52 Mondays become 52 Mondays. Okay? I need one more Monday. That means here 2 days. What are 2 days? Main this is. What are 2 days? Those 2 days are Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday, Sunday. Saturday, Sunday, or Sunday, Monday. These are the choices. 1, 2, 3, 4, 5, 6, 7. Total 7 choices. But my favorable is 52 Mondays came. I need one more Monday. One more Monday means here and here. How many choices are there? Monday, Tuesday, as well as Sunday, Monday. These are two choices. These are two choices means here I have 7 and here I have 2. Guess what will be the probability? Yes, you are correct, I think. So the probability is 2 out of 7. This is 2 out of 7. Required probability is 2 out of 7. How 2 out of 7? Once again I am saying, I am repeating, just check it. Leap 366 days. Here extra 2 days we will have. In these 2 days, maybe those 2 days Monday, Tuesday, maybe Tuesday, Wednesday, maybe Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, Sunday, Monday. Okay? Yes. I need one day extra. One day that should be Monday. Here, Monday as well as Monday. Here, one more day we will get in this one or this one. So that's why 2 out of 7. The answer is 2 by 7. Okay, you got the point. This is about leap year. One more also we will have. See one more problem. Next question. What is the probability of exactly 52 Sundays in non-leap year? Exactly 52 Sundays. Okay? Exactly 52 Sundays. Maybe I think you are following, but here it is not displaying. Okay, let it be. So, what will be the exactly 52 Sundays? If I go through this, yes, so many persons are saying, okay, right. Option B, right. Let me check. What will be the answer? But it will be moved. Okay. So, the probability of exactly 52 Sundays in a non-leap year is how much? This is the question. In a non-leap year means just now we discussed in non-leap year means we will have 365 days. In this 360, 365, not 366 we will have. No, 365 days, correct. 365 days. So, 52 weeks. 52 into 7 plus 1 day. Okay. Here, certainly, compulsory 52 Sundays. 52 Sundays already came. Okay. 52 Sundays. In question, what was given? Exactly 52 Sundays. Exactly. Already 52 Sundays came. Here, what about this day should be? Actually, we will have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay, we have 7 days. Next, my favorable is what? This is the key. What is my favorable? I need exactly 52 Sundays. Already 52 Sundays came. Here the favorable is it may be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, not Sunday. Not Sunday. Why not Sunday? Because in question exactly 52 Sundays. So 52 Sundays already came. Remaining are my favorable. The probability is equal to 1, 2, 3, 4, 5, 6. 6 out of 7. The answer is this one. Okay. Answer is 6 out of 7. Just try to think. 6 out of 7 is answer. Okay? Yes. Let me check. So probability of exactly 52 Sundays. 52 Sundays means in this one day I don't need Sunday. Okay na? So I think sentence is formed very well. In one day I don't need Sunday. Right? Next. See this. The probability of 52 Sundays in leap year. Okay? The probability of 52 Sundays in leap year. This is the question. I need 52 Sundays in leap year. Okay. C question. This is also a little bit of a tricky question. Okay. You need to follow the probability of 52 Sundays in a leap year. Check the question. So, leap year, as we know, leap year means 366. 366 among them 52 into 7 plus 2 days. Okay. What these 2 days will be? It may be Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, Sunday, Monday. So these are the choices. Okay. So Sunday, Monday. Okay na? So these are all choices. Two choices, 2 days. These are all of 2 days. But in my question what was given? 52 Sundays. 52 Sundays means it will have 52 Sundays. 52 Sundays already came. Okay. Now what is my favorable? I don't need Sunday. I don't need Sunday. No need of Sunday means I will take 1, 2, 3, 4, 5. Here Sunday I won't take. Here Sunday I won't take. What will be the sample space? What will be the favorable? M, T, T, W, W, T, H as well as T, H, F, next F, SAT, Saturday. My favorable these are. So with these what will be the answer? The probability of E is equal to 1, 2, 3, 4, 5. 5 out of 7. So the answer is 5 out of 7. Okay. So this is the way to find the problems based on leap year as well as non-leap year. Okay na? So level of difficulty is changing step by step. Okay na? So this is the method to do. Next I will do one more problem. With this I will complete today's session and we will continue in next class. Check the problem. What is the problem? From a pack of 52 cards, yes, 52 cards. Cards means we need to know the difference between cards. Let me write here. Cards, it will be like this. 52 cards will be there. Total among these 52 cards, 26 red cards will be there, 26 black cards will be there. Okay, na? So among these 26 red cards, heart and diamond. These will be, heart will be like this. Next diamond will be like this. And in what do you call black cards, spades. Spades means symbol will be like this. And clubs. Clubs symbol will be like this. Okay. Each contains 13 cards. 13, 13, 13 as well as 13. These will be the cards. How the cards will be like this? The cards will be ace, 2, 3 and so on up to 10, jack, queen, king. Here also A2 up to king. Here also A2, 3 up to king. Here also A2, 3 up to king. Ace means number 1. Okay. Total 13. 10, 11, 12, 13. And these 3 cards are called face cards. Face cards. Okay, face cards, because those cards will have particular face. Okay, yes, face cards. Now let us see our question. See this. From a pack of 52 cards, total 52 cards are there. 2 cards are drawn together at random. From 52 cards, we need to draw 2 cards. Then the question is, what is the probability that both cards are kings? Okay, so here favor is nothing but kings. How many kings we have? 4. Okay, so the probability will be, or the probability of kings will be favor. How many? 4. Among them, how many we need? 2 cards. We need to select 2 cards. See, selection came. Selection is from permutations and combinations. Out of 52 cards, 52 C2. Okay. This is main condition. 4 kings will be there. As you seen, K, 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 K. Total 4 kings. So, among these 4 kings, I need 2 kings. Among these 4 kings, I need 2 kings. Means any 2 kings I can select. Next, total choices. From 52 cards, we can select any 2 cards. This is favor. This is total. Okay. Now you can simplify and say the answer. 4C2. 4C2 is nothing but, I did a shortcut method. 4 into 3 divided by 2 into 1 divided by 52 into 51 divided by 2 into 1. 2 into 1 got cancelled. Okay. So here 4 into 3 divided by 52 into 51. So you can cancel and you can check the answer. What will be the among these. In 4 options, one option will be there. You cancel it and check. Okay. Yes, you can check. And so I think you understood the problems. Okay, you got the problems. So due to little bit of a disturbance, I didn't have phone. That's why I am able to attend in live chat. Okay, whatever. I hope everybody understood. In next class, we will continue same topic. Okay, in next class we will continue same as it is. We will do different types of problems based on this probability. Okay na? I hope you guys understood. And if there is anything, you can comment. I will see later and I will check it once. Thank you very much. Good night.